Okay, now in this opportunity, we're not going to use a determined life table. We want to know which are the probabilities. In other words, we're asking to construct, to build a life table. If we're going to build or construct a life table, we can start with the age, which is represented by letter X, and we say age 0, 1, 2, 3, and 4. These are the ages. And now the radix or initial population is when x is equal to 0. In other words, L0 will be 100, which is the radix or initial population. Now we have the probabilities of dying at every age. Q is representative of the probability of dying. So we have Qx, which will be 0.40, in other words 40%, 0.20, 0.30, 0.70, 70%, and 1, which represents 100. These are the probabilities, and as you can see, something which I wanted to let you know is that at the initial age, at age 0, always there is a great probability of dying, because human beings, when they are born, the most difficult age for continuing living is age 0. From age 0 to age 1, we have mostly a larger number of deaths. Therefore, we have here 40%. Okay. With this specification clarified, we're going to multiply the number of people which will be dying at every age. If we multiply 100 by 0.40, we will have 40 people dying at age 0. And for next line, we will have that Lx is Lx plus 1. Lx plus 1. The next age is equal to Lx less the number of people who will be dying. In other words, we're going to make a difference between 100 and 40. We have 100 at the beginning. 40 people died. We have a remaining persons of 60 persons. Here we will have 12 people, because 60 for 0, 2 will be 12. But let's see, even though this is very, very simple, however, it's better to consider a calculator. Okay, 60 multiplied by 0.2 will give us 12. And 60 less 12 will be 48. We have a remaining persons will be 48. 60 less 12 is 48. 48 multiplied by 30%, that means 14.4. But these are persons alive, so we cannot consider decimal places because we don't have half persons. We have always integer persons. So we take the integer number will be 14. 48 less 14 will have 34 persons remaining alive at age 3, which we multiply by 70% will be 23.8. But 23.8 we have to round to 24 because we do not have persons which are half persons or a quarter of persons. We have only integers. So therefore, we will have 24 persons. And 34 less 24 will be 10 persons. And if all of them are going to die because it's one, number one means 100%, that means that all 10 will be dead. And at age 5, if we had a 5 number, it will be 0 because 10 less 10 is 0, and the probability continues being 1 and will be 0. If we would like to add another line, another row, I hope that with this explanation I have explained much better the idea of living and dying, the probabilities of dying or the probability of living. But at the same time, taking a consideration of this table, perhaps we can ask ourselves another question. What will be the probability that the person age 1 will be alive at age 4? No, we'll be living one more year. Okay, one more year. At the present time, this person, his age is 1. In one more year, the person will be age 2. Now, if I would say, what will be the probability that the person age 1 will be living 3 more years? In this case, this will be 1, and this will be 1 plus 3. In other words, L4. And in this way, we can ask questions and answer at the same time, taking into consideration the probability of living. In this case, we have given a probability of dying because that's why we have built this table with the Q's, which are probabilities of dying. Well, let's continue the next opportunity.